I have a need to make a bunch of small custom-sized keys with a reasonably high degree of precision so that there is really zero slop in the key and keyway. These sizes 1/8 and less, 1/8 and 3/32 in inches, so 3 millimeters to 0.1 millimeters, whatever. And I very quickly came to the conclusion that I need to make some custom parallels. I'm making the keys just from keystock, machining it down on the milling machine. But how? So if you stick the keystock out of the milling machine, then it's floppy and it's not accurate. You can't get accurate dimensions because the keystock is so small that it just bends under the cutting forces. If you keep it in the vise, then either you've got to dial it in the flat surface, the parallel surface, all the time, or you've got to have a parallel under it. But this is small stock, so all of the thinnest parallels I have is 1/8 of an inch, and this is going to be less than 1/8 of an inch. So I can't use my parallels. So I need a custom thin parallel. I found a piece of stainless steel. It's sheet metal basically. It's actually off an appliance. It's like some kind of trim strip for an appliance. And it's about 24 thousandths of an inch thick. So that will do. That's thinner than the keys that I want to make, and so I'm going to use that as stock for the parallels. But there's a bit of a catch-22 here. To make a parallel, you just have to drop it in the vise and machine one surface, flip it over and machine the other, and then you're going to have a parallel essentially to the accuracy of your machining. The problem is I need a parallel that's lower than the vise jaws, so that by 1/2 to 3/4 of a key, the size of a key, so that I can just drop the parallel in and then drop the key on top of the parallel, clamp it and fine-tune the thickness of the key. But now, how do I bring the parallel up to machine it while keeping parallelism? I need another parallel underneath it. Oh, but that has to be a thin parallel as well. But the whole point is making thin parallels. Catch-22. So, this is what I tried. What I'm doing is making a third parallel from a feeler gauge. So this feeler gauge is 16 thousandths of an inch, 40 microns. So it's thinner than the stock I'm using for the thin parallels. And so is this parallel though? So that needs to be checked. I took a feeler gauge, this one is 1/2 inch wide nominal, and it's actually quite close to parallel. So I measured it up and just lapped it a little bit to take any burrs off, and then also just a little bit more to get it down to parallel within, I would say, 1 to 2/10 of the best I can measure with my equipment and my skill level. So that'll do, I think, to be the base parallel. So now I can use that to put in the bottom of the vise jaws, sit the parallels on top and machine them. Problem is, now they're going to stick up above the vise jaws, and this is sheet metal, and it's going to flex. The force of the cutting forces are just going to rattle that all around. So that's the next trick. How do you machine them cleanly without them just vibrating themselves to bits? I don't know. My plan for holding the thin parallels to machine them is to sandwich them between two regular parallels clamped in the vise with the feeler gauge thin parallel at the bottom to maintain the parallelism of the two edges of the thin parallel I'm trying to make. And then I can make this distance here really small so that the sheet metal will be adequately supported for end milling and maintain the parallelism. So that's the plan. So that's what it ended up looking like. There's the thin parallel clamped between regular parallels, and you can see the bottom thin parallel under there just supporting the parallel to be machined. It's a bit fiddly getting everything set up. So here the big parallels are sitting right down in the bottom of the vise, and the thin parallel to be machined is sitting on top of the small thin parallel, the assisting thin parallel, but now it's sticking out way too much, of course. So with just enough tension on the vise to allow things to move, I then just slide the big parallels up like so, and then clamp up. This is how the parallels turned out after milling. So this one is pretty parallel to the best of my ability to measure it. It's 1.3108 inches wide, 108 at both ends, so within a tenth to my ability to measure a tenth. This one was 1.301 and 3093, so 8/10 of a thou in 4 inches or 100 millimeters length. So that maybe I didn't tap it down properly, I don't know. So that wasn't so good. So what I did, I lapped them by hand, and this is the progress you can see. So what I ended up with is 1.3093 here and 1.3094 here, and I'm getting, you know, about a tenth difference end to end, and here 93930 end to end. But you know, my ability to measure a tenth is, you know, pretty doubtful. So that's as good as I can get, I would say. And just a note on measuring, it's really quite fiddly. I found it quite difficult to measure because they're so narrow that they rock in the anvils, and you have to find the high point. And it's really quite finicky. So just try to get the same feel on every single one. So yeah, it was interesting. And I made two parallels because it's always good to have a pair. For instance, this is only 24 thou thick, so if I'm doing a 1/8 key, it would be great to have two parallels to support it rather than just one. If they were wavy, it would be great, but I don't trust my ability to make them wavy without ruining the parallelism. So I made two, but catch-22 again, because two won't sit on my setup parallel, the feeler gauge. So I made them separately and individually, and then made them the same by hand lapping. So they're probably not quite the same, but for the accuracy that I work to, that I'm able to work to, it's probably enough. So a little bit more laborious than, you know, obviously better to do two at once. But then you run into this catch-22. To make a parallel, you need a parallel. And it's been quite an interesting process. So there it is. A couple of parallels for making small parts. Drop the parallel in. Drop the key on top of the parallel. Clamp it up and Bob's your uncle. So that's going to make it a lot easier to make small custom keys. Here you can see the tiny key sitting on two parallels. That's a 1/8 key, or just under a 1/8. One thing I wish I'd done differently is the length of the parallels. I made them essentially the same width as the vise. The length of the parallel is the width of the vise. But that wasn't very smart, because when you slip them in and you want them out again, it's almost impossible to get hold of them. So it would have made a lot more sense to make them a little longer so you can get hold of them. And then this is the setup for just cleaning out the ends. That's more cosmetic than anything. Don't laugh at my huge 3/4 inch end mill in my small milling machine. It's just one that I found that has enough flute length to do the side milling in one pass. And besides, it came in a box with a whole bunch of others from an auction for about $40, and about 60% of them are brand new and decent quality brands. So there it is, two new ultra thin parallels to enable me to do my tiny keys, custom keys. That was a fun exercise. They are reasonably accurate to the extent that I'm capable of, and but it should be accurate enough for what I do. I hope you've enjoyed something, or learned something, or laughed at something. Thanks for watching, and bye for now. And just by way of postscript, here are the completed keys fitted in the shaft, and they turned out really well. The fits are really good. So this is for a fixture, so I wanted the fits to be super tight, so that gear is just, I can't even push it on. It's actually a tap-on fit, so that's perfect for what I wanted. No slop whatsoever. And some of these keys are super small. That one's for in the end there. So parallels are very successful in helping me to make these small custom keys. Parallels work fine for even my smallest keys. Tweezers useful, and heaven help you if you drop it on the floor. These small pieces. Ask me how I know.